Here it is, finally. Problem number 16B 407. So I want you guys to work on that. You can work on it by yourself, but feel free to unmute yourself and ask each other questions. I'm going to stand out. I'm going to stay out of it for a few minutes and let you kind of struggle through it. I want to see what you guys come up with. All right. So simplify this subtraction problem, and I'll check in with you in a minute.
What'd you guys get?
I don't know what they exactly mean by saying determine the domain. So does that mean like solve for x or something?
It means you got to tell where the fractions have restrictions, where the fractions are going to be broken.
Oh, right. Okay. And we're gonna so should we also be solving for that as well?
Yeah, that's like a separate question.
Okay.
Sometimes when they're easy, though, you can figure it out by inspection. I'll show you. It looks like you guys have, for the most part, have come to some closure on it. Let's check and see how you did and what it should have come out as. So before we begin, we have to decide what is the, it's a subtraction, right? So in order to subtract, what's necessary to subtract fractions?
The denominator.
Yep. So we got to figure out what is a common denominator for this, for these two fractions.
2x parentheses x plus 5 close parentheses.
Yep. Since these guys have nothing in common, the only way to get a common denominator is to multiply the two of them together so that I have something that's big enough for both to go into. Now that means each fraction has to become switched to the new denominator. So what am I going to do to this first fraction to change it into its new denominator?
1.
Exactly. I have to multiply by the right kind of one, though. It can't be just any number one. It has to be a fancy one to switch this to, yeah.
2x.
Yeah. I have to have 2x over 2x. Now, the 2x times the group x plus 5, I'm just going to leave it. 2x times the group x plus 5. But on the top, I'm going to get rid of parentheses because later on I have to add, and the only way to add the top numbers is to have all the parentheses gone. So I'm just going to go ahead and multiply 2x times 3x, which is 6x squared. This problem seems familiar. I'm wondering if we did this before. But let's keep going. Now, the second fraction also needs some changing. What do I multiply to the second one? Well, it already has a 2x in it, but it doesn't have the x plus 5 factor in it. So to build this guy up, I'm going to have to multiply by the group x plus 5 on the top and the bottom. Now, the 2x times x plus 5, I'm leaving the groups and the multiply on the bottom, but on top, eventually I'm going to have to subtract. I didn't write subtract. That was a bad move right there. That's a minus. Eventually I'm going to have to take the top minus the top. So if I leave the parentheses here, I won't be able to subtract. So I'm going to need to FOIL the top here. And so I'm going to go ahead and multiply first, outer, inner, last. And I will get x squared plus a 5x plus a 1x is plus 6x. And 1 times 5 is 5. Now, I got my common denominator. Both fractions are the same. What is going to happen with this subtraction? Do I just subtract x squared?
Would you subtract 1 from one of the x squared or one of the x's from the 6x and then carry over the 6x plus 5x? I mean, plus 5?
Yes, we are going to have 6x squared minus x squared, and we're going to have a 5x squared. So 6 minus 1 makes the 5x squared. Is that it? If I just do that subtraction, am I all good?
I thought you would just carry the rest over.
What do you mean carry the rest over? You mean the 5 and the 6x and bring those over?
I mean, distribute.
Yes.
So be careful here, Rhiannon, because when I subtract, I'm not just subtracting this one.
It's the whole.
I'm minusing the whole group. Now, they're not on here, but this is a group, so you have to realize, oh, there's parentheses here. I'm subtracting that whole group. So technically, I've got this problem, 6x squared, and when I subtract the whole group, I have to distribute that. Somebody said that, and that's actually correct. So I'm going to have a minus for the x squared, but the 6x is also going to become a minus 6x. And the 5 is now going to become a minus 5. Now, some of you are kind of better with polynomials than others, but if you're a little rusty with subtraction, make sure you write that step down and distribute the subtraction. And then simplify. 6x squared minus x squared is 5x squared minus 6x minus 5 over 2x times x plus 5. It's not going to factor. And since it doesn't factor, we can't reduce, so this is the final answer right here.
So we leave the 2x and the x plus 5 alone. We don't distribute the 2x to the.
Correct. Because you don't really, it's not wrong, but we didn't gain anything by distributing.
53 bucks on Amazon.
So these are both true, but it just meant more work. To get this last one, it took me one more step. So it was just more work. If we stop here, though, we're good because it's still a correct answer. The distribution or foiling?
The foiling's where it got me. Now, yep, right there.
So group times a group, that required FOIL.
Mm-hmm. I
2x times 3x minus, there's still that minus though. X plus 1, x plus 5 over 2x times x plus 5. Because of the minus here, we can't cancel.
Yeah.
That's where that went south for you. Anybody want to ask questions about the other steps I did, things that aren't quite too clear or?
Well, I see what I did wrong.
Well, that's wonderful. I mean, that's learning. That's where you're learning. Good job. If you can see a mistake. So now once you've learned that, you kind of take it with you the next time you do a problem and get better next time. I want you to do one more problem, just as a quick assessment, see how you're doing. Adding and subtracting are harder. We did the hard one first. I have an easier one for you. It's on page 409. Page 409. Problem 20, part A. That says division. So let's check and see how we should solve this problem. Now, it's a division problem. So how do we do division problems?
We multiply by the reciprocal of the second.
Exactly. And the second one is the reciprocal. So where does the x minus 3 go?
That's the numerator.
Yep. And the 12 gets flipped. What about the first one? Do we flip it?
No.
Right. Now, since we're getting ready to multiply we like. It's easy, especially when we can factor. So instead of just rewriting the bottom the same again, let's also get ready to multiply. So we're switching division to multiply, and let's start factoring so we can do the multiply fast. And 3x minus 9 does factor. There's a common 3 here. And now that it's multiplied, I can start dividing common factors. And you can probably tell, oh, x minus 3 is going to cancel. Anything else?
Entries simplify 4 and 12 by 3.
This is a multiply. And this is a divide. You're
can reduce
multiplying
it.
by 4, dividing by 12. There is a common factor of 4 that goes into both of these. 4 goes into itself once. 4 goes into 12 3 times. Now this is a little sloppy with all this canceling, so we look carefully, don't miss anything. But it's just 1 times 1. When I canceled this one, I got a 1. So I have 1 on top. And then I have a 3 times a 3, 9 on the bottom. That's my simplified answer. This really complicated division, once I switched it to multiply, was easy, and it just came out to this really simple answer. And we did it in 1 step. So you practice that, you'll get better at this so that you can get the division answers in really just 1 step, maybe 2 max.
Oh, I was saying I had some trouble with adding on our homework.
Yep. This adding stuff is by far the hardest. In fact, I would say this is some of the hardest algebra in our course right here, is keeping track of all of this. Now, it's not, I don't want to say hard like it's like you can't do it, but what I mean is it's complicated. And it's complicated because it has lots of parts, many steps, and we have to do many different steps. But each step is easy. That is an easy thing to do right there. That's an easy step. And that is an easy step. You just have to realize it's a little complicated because there's many parts to this. Once we do this fancy one, then we also have to FOIL it. But you guys, you can do that part. So that little step is simple. It's just that there's lots of steps that make these adding and subtracting problems complex. But each step is a simple thing, and it's just a matter of practicing so you can put all those simple steps in order. But I know that this is some of the toughest stuff you will ever do in algebra, is adding and subtracting fractions. So don't feel bad if that was a challenge. It does take some work getting used to that. Okay, I have one more thought. As I was asking you, I saw something I want to talk about. In 4.3, these fractions here, we call them complex fractions. They're complex fractions because they're fractions with fractions in them. This one is a complex fraction level 1, and problem C is a complex fraction level 2. It's a really complex fraction. Problem B isn't so bad because B is 1 fraction on the top, 1 fraction on the bottom, and you might skip this step, but you can switch this fraction into division. A lot of people skip that. And so it's x minus 2 over 2 plus 2x. So instead of having a fraction over a fraction, we made it a division problem. Now, as a division problem, we realize, oh, I can switch this to multiplying. And then I'm going to move 2 plus 2x on top. And when I do, there's a common 2 in here. I'm taking it out. And I'm going to move x minus 2 to the bottom. And then I'm going to look to cancel. Does anything cancel? Do we got something on the top that will cancel with something on the bottom? Nope. It's a shame. This is the same and this is the same. We'd like to cancel them, but they're both on the bottom. They don't cancel. They multiply. And the same with the x plus 1s. They're both on the top. So in this problem, there is no canceling. It's 1 plus x times 1 plus x. I'm just going to be lazy and write it as a second power. And it's x minus 2 times x minus 2. I'm going to write that as a second power. And that division is all done. We can't really do much to it at the end. But I'm not testing this type. So the difference here is we're adding 2 fractions on top versus this one here where it's just 1 fraction on the top. But I think I'm going to call it quits now. 4.3 is done.